This STRUREL online presentation is about how to employ a Python limit state function in STRUREL. Assuming you have a Python model of your system of interest and now you want to perform a structural reliability analysis on it using COMREL, this video explains how you can integrate your Python model into COMREL. This online presentation specifically targets Python. However, interfaces to many more programming languages are available in STRUREL. Before we start, you should ensure that some version of Python is already installed on your system. If Python is not already installed, please install it now. Furthermore, please make sure that the Python interface of COMREL is installed alongside COMREL, as it is an optional module. Now, please open COMREL. In the lower right of the window, you should see a Python icon. This indicates that the Python interface was loaded successfully. If you only see a red cross instead of the Python icon, it probably means that COMREL could not detect the path to your Python installation automatically. In this case, click in the menu on View and then on Preferences, go to the section Add-ons and ensure that the path specified in the Python entry points to the correct location of your Python DLL. Let's set up a small toy example. We start by creating the Python script file, which we name mymodel.py. We open this file. And important here is that the last line in this file is always something with res equals the limit state function that you are trying to investigate, where res in this case stands for result, and it's the variable that is handed back to COMREL, and the limit state function is the function that you want to process. In our case, it's simply r minus s, where r stands for a random variable representing the resistance of a system, and s stands for the random variable representing a load on a system. These two random variables, r and s, we have to define later on in the stochastic module of COMREL. In COMREL, we set up a new project file, and in the stochastic model of our project file, we have to define the same random variables that we also used in the Python script file. In our case, this are r and s. The resistance random variable r is a log number random variable with a mean value of 5 and a standard deviation of 1. And the load random variable s is a nominal random variable with a mean value of 2 and a standard deviation of 0.5. It is very important that the spelling of the random variables is the same in the stochastic model as in the Python script file. It matters also if the letter is written in upper or in lowercase, or the name is written in upper or lowercase. In the symbolic expression, we define limit state function 1 as flim1, which equals in our case Python s. So the limit state function is taken from a Python script file with name mymodel, meaning the name that we gave to our Python script file without the .py. Now let's save this project. Use the name test. Then we parse it. And now we should be able to run the reliability analysis, which is a form analysis by default. And we see that the result gives us a beta value of 3.2 and a probability of failure around 7 times 10 in the power of -4. As the employed limit state function of r minus s is very simple, we can cross-check our result by using STRUREL's inline scripting language. For this, we define a second limit state function flim2 equals r minus s. We make sure that it is parsed by COMREL, and then when we click on Run Reliability Analysis, we can select the second limit state function flim2. And once the analysis is complete, we get exactly the same results as we got when running the Python-based limit state function. In practice, you will unlikely want to use the Python interface for limit state functions as simple as the one we used in our toy example. However, limit state functions in the Python script file can be significantly more complex without changing the general procedure explained in this video. Just remember to assign the result of your limit state function evaluation to a variable called res. If you watched this far, I'm sure you like this channel, so hit that subscribe button.